Her name was Clara. Her husband was Henry Ford, the most powerful man in the automobile industry, the man who revolutionized manufacturing, the man who put America on wheels, the man whose name became synonymous with the gasoline-powered car. She refused to drive his product. Clara Ford drove an electric car, and not just once or twice, as a curiosity or an experiment. She drove electric cars as her primary means of transportation for over 20 years. From 1908, when Henry bought her first one, all the way into the late 1930s. Her car was a Detroit Electric, a beautiful, elegant machine built by the Anderson Electric Car Company in Michigan. It started with the push of a button. No cranking, no struggling, no danger, just push and drive. It never needed gasoline, not a single drop, ever. It never needed an oil change. It never needed a new muffler or a transmission repair or any of the 100 things that gasoline cars constantly demanded. She would plug it in at night in her garage at Fairlane, the Ford estate. In the morning, it was ready, fully charged, waiting for her. And here's what made it remarkable. It could travel 80 miles on a single charge. In 1914. That was more than enough for a full day of errands, social calls, shopping trips, and visits to friends. She never worried about running out of power. The technology worked. Clara Ford was not a fool. She was not ignorant about automobiles. She was married to the man who understood them better than almost anyone on Earth. She watched the industry develop from its earliest days. She knew every argument for and against every type of vehicle, and she chose electric. But here's the thing. She wasn't unusual. She wasn't eccentric. She wasn't some radical environmentalist ahead of her time. She was normal. Electric cars were normal. In the year 1900, nearly 4 out of every 10 automobiles on American roads were electric. Not 4%, 4 out of 10. Exposed statistics from the United States Department of Energy show that 38% of all cars were electric, 40% were steam-powered, and only 22% ran on gasoline. The gasoline car, the technology that would come to dominate the entire 20th century, was in last place. Thomas Edison, the greatest inventor in American history, drove an electric car. He built 3 of them with his own hands. He spent years of his life developing better batteries specifically for electric vehicles because he believed they were the future of transportation. The First Lady of the United States, Helen Taft, drove an electric car around Washington, D.C. The White House had electric vehicles in its fleet. The streets of New York City, Chicago, Boston, and Philadelphia were filled with electric cars. Thousands of them. They were everywhere. This is not a myth. This is not revisionist history. This is not some conspiracy theory invented by electric car enthusiasts. This is the documented, verified, official, historical record. So here's my question for you. If your great-great-grandmother could drive across town without buying a single drop of gasoline, if the technology existed and it worked and people loved it, then why did your grandmother have to wait in line for hours during the oil crisis of 1973? Why did your mother spend tens of thousands of dollars on gasoline over her lifetime? Why did your family expose their entire financial planning around the price of oil? Why are you still paying for gas today? The answer is not that electric cars failed. The answer is not that they couldn't compete. The answer is not that consumers rejected them. The answer is that someone stopped them. And I'm going to tell you exactly how it happened. to understand what we lost. And make no mistake, we lost something profound. We need to go back to the very beginning of the automobile age. The year is 1900. The automobile itself is barely more than a decade old. Carl Benz built what most historians consider the first true automobile in 1885. By 1900, the technology is still in its infancy, still experimental, still undefined. And here's what's crucial to understand. Nobody knew what was going to power it. This might seem strange to us today when we assume that cars run on gasoline and always have. But in 1900, that assumption didn't exist. The internal combustion engine was just one option among several. And frankly, it wasn't the most popular one. Three technologies were competing for dominance, and each had passionate advocates who believed their approach was the future. First, there was steam. Steam power was the conservative choice, the safe bet. Humans had been using steam engines for well over a century by 1900. Steam powered the Industrial Revolution. It drove the locomotives that connected the American continent. It propelled ships across oceans. The technology was proven, understood, and trusted. The Stanley Steamer was the most famous steam-powered car, and it was genuinely impressive. In 1906, a Stanley Steamer set the world land speed record at over 127 miles per hour, faster than any gasoline car of the era. Steam cars were powerful and reliable once they got going, but they had serious problems. Starting a steam car was an ordeal. You had to light a fire under the boiler and wait for the water to heat up and build pressure. On a cold winter morning, this could take 30 minutes, sometimes 45. You couldn't just decide to go somewhere. You had to plan ahead and start heating your car long before you wanted to leave. And then there was the water. Steam cars consumed water constantly. You had to refill the tank frequently, which meant planning your routes around water sources. Long trips required careful logistics. But the biggest problem was safety. Steam boilers operated under tremendous pressure. If something went wrong, a faulty valve, a crack in the metal, a pressure buildup, the boiler could explode. And when a steam boiler exploded, it was catastrophic. People died. Bystanders were injured. The car was completely destroyed. Steam cars were powerful, but they were also dangerous and inconvenient. Most people who could afford an automobile wanted something easier. Second, there was gasoline. The internal combustion engine was the ambitious choice. The technology was newer and less proven than steam, but it offered one major advantage: range. A gasoline car could travel farther on a tank of fuel than a steam car could on a tank of water, or an electric car could on a battery charge. For some buyers, especially those in rural areas or those who wanted to take long trips, this range advantage was decisive. But gasoline cars in 1900 had a problem. A serious problem. A problem that injured thousands of people and killed dozens. Starting one could destroy you. There was no ignition key in 1900, no electric starter, no push-button start. To start a gasoline engine, you had to physically crank the crankshaft by hand. Here's how it worked. You would walk to the front of the car, where an iron crank handle protruded from the engine compartment. You would grip this handle carefully with your thumb on the same side as your fingers, never wrapped around, and begin to turn it. The crank was connected directly to the crankshaft inside the engine. By turning it, you were physically rotating the engine's internal components, trying to get the pistons moving fast enough for the spark plugs to ignite the fuel. This required significant physical strength. You had to turn the crank fast enough, with enough force, to get the engine to catch. It was exhausting work, especially in cold weather when the oil was thick and the metal was contracted. But the real danger came from backfires. If the ignition timing was slightly off, or if the fuel mixture wasn't quite right, the engine could backfire. When this happened, the crank would suddenly spin backward with tremendous, violent force. If your hand was on the crank when this happened, the results were devastating. Broken wrists were so common that doctors gave the injury a specific medical name, chauffeur's fracture. But wrists were just the beginning. People suffered broken forearms, dislocated shoulders, fractured elbows. The crank could strike you in the chest, in the face, in the jaw, and sometimes it killed. In 1910, a man named Byron Carter was driving across a bridge in Detroit when he saw a woman stranded on the side of the road. Her car had stalled, and she couldn't restart it. Carter was a gentleman, and he was also an expert. He was the founder of the Carter Car Company, a successful automobile manufacturer. He knew cars better than almost anyone. He offered to crank the engine for her. The engine backfired. The crank spun backward with full force and struck Byron Carter directly in the jaw. The impact shattered bone. He was rushed to the hospital where doctors did what they could, but in 1910, medicine had limits. The wound became infected. Gangrene set in. Byron Carter, entrepreneur, innovator, automobile pioneer, died a few weeks later, killed by a hand crank, and he was far from alone. Thousands of people were injured every year by hand cranks. Starting a gasoline car wasn't just difficult, it was genuinely dangerous. And then there was the third option: electric cars. No boiler to explode. No hand crank to shatter your bones. No gasoline fumes to make you sick or stain your clothes. No deafening engine noise to disturb your neighbors or frighten horses. An electric car in 1900 was a revelation. You simply sat down in the driver's seat. The interior was clean and elegant. No grease, no oil stains, no smell of fuel. You pushed a lever or pressed a button, and the car began to move, silently, smoothly, effortlessly. There was no warm-up period like a steam car. There was no dangerous cranking like a gasoline car. You just drove. Electric cars were quiet. So quiet that you could have a conversation in a normal voice while driving. So quiet that you didn't disturb your neighbors when you left for work early in the morning or came home late at night. So quiet that horses, which were still everywhere in 1900, didn't spook when you passed them. Electric cars were clean. There was no exhaust pipe belching smoke. No oil dripping onto your carriage house floor. No gasoline smell on your gloves after you filled the tank. Ladies in white dresses could drive electric cars without fear of ruining their clothes. Electric cars were safe. No explosions, no fires, no kickback injuries. The worst that could happen was that your battery ran out of charge, and then you simply stopped. Inconvenient, perhaps, but not dangerous. And here's something that might surprise you. The infrastructure already existed. In major American cities, there were public charging stations where you could recharge your electric vehicle while you went about your business. These weren't rare curiosities. They were common, established businesses. By 1912, there were hundreds of charging stations in New York City alone. You could drive your electric car to the shopping district, plug it in at a charging station, do your shopping for a few hours, and return to a fully charged vehicle. The system worked. Jay Leno, The famous car collector who owns hundreds of rare and antique vehicles has several early electric cars in his collection. He's driven them. He knows them intimately. Here's what he says about them. These were women's shopping cars. There was no gas or oil, no fire, no explosions. You just sort of got in and you went. There were thousands of these in New York from about 1905 to 1915. There were charging stations all over town, so ladies could recharge their cars while they were in the stores. This wasn't a primitive technology waiting to be replaced by something better. This was a mature, functional, beloved technology that served its users well. Thomas Edison understood this better than anyone. Edison didn't just dabble in electric cars, he committed to them. He believed with the full force of his considerable intellect that electric vehicles were the future of transportation. He spent years of his life developing the nickel-iron battery, a new type of rechargeable battery specifically designed for electric vehicles. He believed this battery would solve the range problem once and for all. In 1903, Edison declared, "I believe that ultimately, the electric motor will be universally used for trucking in all large cities, and that the electric automobile will be the family carriage of the future. All trucking must come to electricity. I am convinced that it will not be long before all the trucking in New York City will be electric." And he put his money where his mouth was. In 1910, Edison personally drove an electric car on a 1,000-mile promotional tour from New York to New Hampshire, charging at stops along the way. He wanted to prove that electric vehicles were practical for long-distance travel, not just short urban trips. This wasn't some eccentric stunt. This was Thomas Edison, the most famous inventor in the world, the man who gave humanity the light bulb and the phonograph and the motion picture camera, telling the world that electricity was the future of transportation. The numbers backed him up. In 1900, according to the U.S. Department of Energy, electric vehicles held 38% of the American automobile market. Steam held 40%. Gasoline held just 22%. The gasoline car was in last place. Electric vehicles weren't a niche product. They weren't a curiosity for eccentric millionaires. They were a mainstream technology, competitive with or superior to every alternative. And Clara Ford, wife of the man who would soon dominate the gasoline car industry, looked at all the options available to her and chose electric. She kept choosing electric for over 20 years. So what happened? What changed? How did electric vehicles go from 38% of the market to essentially zero? The answer involves oil, technology, and possibly something darker. The electric car did not die of natural causes. It did not fade away because consumers lost interest. It did not disappear because a better technology came along and won a fair competition. The electric car was killed. It happened in 3 stages, over about 15 years. 3 shots that together destroyed an industry and shaped the next century of human civilization. The first shot, oil January 10th, 1901, Spindletop Hill, about 4 miles south of Beaumont, Texas. For months, a Croatian-born mining engineer named Anthony Francis Lucas had been drilling into this small hill on the flat, Texas Coastal Plain. Lucas had a theory about salt domes, underground formations of rock salt that sometimes trapped petroleum deposits against their sides. The established experts in the oil industry thought he was wasting his time. The geology was wrong, they said. There was no significant oil in southeastern Texas. Lucas should give up and go home. But Lucas persisted. He found investors willing to take a chance, and he kept drilling. On the morning of January 10th, the drill reached a depth of 1,139 feet. The drilling crew was changing out a worn bit when they heard a strange sound from deep underground. A rumbling. Then the ground began to shake. Mud started shooting up out of the drill hole, then gas. The crew barely had time to run before a geyser of black crude oil exploded from the earth with the force of a bomb. It shot 150 feet into the air, higher than the drilling derrick itself. The roar was so loud it could be heard miles away. Oil rained down on everything: the equipment, the workers, the surrounding land. The Lucas Gusher, as it came to be known, produced approximately 100,000 barrels of oil per day. To put that in perspective, at that moment, every other oil well in the entire world combined was producing less than the Lucas Gusher alone. It took 9 days to bring the well under control, 9 days of oil fountaining into the sky, pooling on the ground, forming a black lake around the drill site. Word spread instantly. Within weeks, Beaumont was transformed from a quiet town of 10,000 people into a chaotic boomtown of 50,000. Fortune seekers, investors, speculators, con men, roughnecks, and opportunists of every description flooded into southeastern Texas. By the end of 1902, there were over 285 active wells at Spindletop. The Texas oil industry was born. Companies that would become Gulf Oil, Texaco, and eventually Exxon were founded in the chaos of those first months, and the price of oil collapsed. Before Spindletop, oil cost approximately $2 per barrel. After Spindletop, with supply vastly exceeding demand, the price crashed to 3 cents per barrel. 3 cents. At that price, oil was cheaper than water. You could buy a barrel of crude oil for less than the cost of a glass of milk. Gasoline, which was refined from crude oil, became almost worthless. It had been an expensive fuel, competitive with the cost of electricity for powering vehicles. Now it was practically free. Think about what this meant for the electric car. Electricity cost money to generate. It cost money to transmit through power lines. It cost money to store in batteries. Every mile you drove in an electric car had a real, measurable cost associated with charging the battery. But after Spindletop, gasoline cost almost nothing. The fuel itself was essentially free. The only costs were refining and distribution, and those were dropping rapidly as the industry scaled up. The fundamental economics of transportation had shifted overnight. Electric cars still had advantages. They were quieter, cleaner, easier to operate, safer, but now they had a significant disadvantage. Their fuel cost more. The oil industry understood the opportunity immediately. They needed customers for all this cheap petroleum, and automobiles were the perfect customer. A new, growing market that could absorb enormous quantities of fuel. But cheap oil alone wasn't enough to kill the electric car. There was still the problem of the hand crank. As long as starting a gasoline car remained dangerous and difficult, many buyers would still prefer electric. Which brings us to the second shot. The second shot. Technology. Byron Carter's death in 1910 had a profound effect on Henry Leland, the founder of Cadillac. Leland had known Carter personally. They moved in the same circles, successful automobile manufacturers in the Detroit area. When Carter died from a hand crank injury, Leland was shaken. He became obsessed with finding a solution. If only there were a way to start a gasoline engine without the dangerous hand crank. If only there were some mechanical or electrical system that could turn the crankshaft automatically. Leland turned to a young electrical engineer from Dayton, Ohio, named Charles Franklin Kettering. Kettering had already made a name for himself by inventing the first electric cash register for the National Cash Register Company. He understood electrical systems, he understood motors, and he understood how to make complex technology simple and reliable. Leland gave him the challenge: create a system to start a gasoline engine without a hand crank. Kettering's insight was elegant in its simplicity. What if you used an electric motor, a small battery-powered motor, to spin the crankshaft? The motor wouldn't need to be powerful enough to actually drive the car. It would only need to be powerful enough to turn the engine over a few times fast enough for the spark plugs to ignite the fuel and get the engine running on its own. Once the engine was running, the motor could stop. Its job was done. Kettering worked through the technical challenges. The motor needed enough torque to turn a cold engine with thick oil. The battery needed enough capacity to power multiple start attempts. The gears needed to engage and disengage smoothly. The whole system needed to be reliable enough for everyday use. By 1911, Kettering had a working prototype. He demonstrated it for Henry Leland, who was immediately convinced. In 1912, Cadillac introduced Kettering's electric self-starter as standard equipment on all their vehicles. It was revolutionary. Instead of walking to the front of the car and cranking, risking injury with every start, you simply sat in the driver's seat, turned a key, and the engine roared to life. Safe, easy, reliable. Anyone could do it. The electric starter spread rapidly through the industry. By 1920, it was standard on nearly every car in America. By 1920, the hand crank was obsolete. And here's the bitter irony that should make every electric car enthusiast want to scream. The electric starter was an electric motor. The same fundamental technology that powered electric cars was used to save the gasoline car from extinction. Before the electric starter, electric vehicles had one overwhelming advantage that justified their higher price: ease of use. Anyone could drive an electric car. It was safe and simple. Gasoline cars were dangerous and difficult, suitable only for those with strength and mechanical aptitude. After the electric starter, that advantage vanished overnight. Now gasoline cars were just as easy to start as electric cars. You turned a key, the engine started, you drove away. But gasoline was still dramatically cheaper than electricity, and gasoline cars could still travel farther on a tank of fuel than electric cars could on a battery charge. The electric car's primary advantage had been neutralized. Its primary disadvantages remained. And then Henry Ford delivered the final blow, not with technology, but with economics. Ford's assembly line manufacturing methods revolutionized the automobile industry. By standardizing parts, simplifying designs, and optimizing every step of the production process, Ford drove the cost of the Model T down relentlessly. In 1908, a Model T cost $850. By 1916, it was $360. By 1925, it was just $260. Meanwhile, a comparable electric car, like Clara Ford's Detroit Electric, cost over $2,500, nearly 10 times as much. When gasoline was expensive, when starting a gas car was dangerous, when electric cars offered genuine advantages in convenience and safety, many buyers were willing to pay the premium for electric. But when gasoline was nearly free, when starting was easy, and when a gasoline car cost a tenth of the price, The math no longer worked. Electric car sales, which had been growing steadily, began to decline after 1912. By 1920, they were a tiny fraction of the market. By the mid-1930s, production had essentially ceased. The electric car was dead. Or was it? The third shot, sabotage. Here's where the story takes its strangest and most disturbing turn. Even with cheap oil and the electric starter, even with the Model T's devastating price advantage, the electric car still had a chance. Because Henry Ford himself, the man who had done more than anyone to destroy the electric car market, tried to bring it back. In January 1914, newspapers across the country reported a shocking announcement. Henry Ford and Thomas Edison, arguably the two most famous and respected businessmen in America, were joining forces to build a cheap, mass-produced electric car. Ford told the New York Times, "Within a year, I hope, we shall begin the manufacture of an electric automobile. The problem so far has been to build a storage battery of lightweight which would operate for long distances without recharging. Mr. Edison has been experimenting with this for some time." The plan was ambitious and, coming from Ford and Edison, entirely credible. The price would be between $500 and $750, far cheaper than any electric car on the market, and competitive with the Model T. The range would be 50 to 100 miles per charge, enough for virtually any daily driving need. It would be mass-produced on Ford's revolutionary assembly lines, bringing the same economies of scale that had made the Model T affordable. It would be powered by Edison's new nickel-iron batteries, which promised to be lighter, more durable, and longer-lasting than the lead-acid batteries used in existing electric cars. Ford invested $1.5 million in the project, equivalent to nearly $50 million in today's money. This was not a casual experiment. This was a serious industrial effort backed by serious capital. Edison was enthusiastic. In May 1914, he told the press, "Mr. Henry Ford is making plans for the tools, special machinery, factory buildings, and equipment for the production of this new electric. Mr. Ford is working steadily on the details, and he knows his business, so it will not be long." The trade magazines buzzed with anticipation. The Wall Street Journal covered every development. The automotive world held its breath. The Ford Edison electric car was coming. It would revolutionize transportation all over again. It would give consumers a clean, quiet, efficient alternative to the gasoline car. It would change everything. And then, nothing. On the night of December 9th, 1914, a massive fire swept through Thomas Edison's laboratory complex in West Orange, New Jersey. The fire was catastrophic. Multiple buildings were destroyed. Decades of Edison's work, prototypes, research notes, experimental equipment, went up in flames. The damage was estimated at several $million, an enormous sum in 1914. Edison, who was 67 years old, reportedly watched the fire and told his son, "Go get your mother and all her friends. They'll never see a fire like this again." He rebuilt, of course. Edison was not a man who gave up easily. Within weeks, temporary structures were going up. Within months, production had resumed. But the Ford Edison electric car project? It simply stopped. No announcement, no explanation, no press release explaining what had happened or when the project might resume. The prototypes, whatever had been built, vanished. The plans were shelved. The collaboration dissolved. Ford never publicly explained why he abandoned the project. Neither did Edison. The greatest potential electric vehicle partnership in history ended without a word. Some historians blame technical problems. Edison's nickel-iron batteries, while durable, had high internal resistance. They couldn't deliver power quickly enough for the kind of acceleration Ford's engineers wanted. The batteries worked well for steady, gentle driving, which was why Clara Ford loved her Detroit Electric. But they struggled with the demands of a mass-market vehicle. Other historians blame Ford's notorious temper. According to some accounts, Ford had insisted that only Edison batteries be used in the electric car. When engineers secretly substituted lead-acid batteries to make the prototypes work better, Ford discovered the deception and was furious. He killed the project rather than admit that Edison's batteries weren't up to the task. But some people look at the timing and wonder if something else was going on. In 1914, the Rockefeller family's oil interests dominated the American petroleum industry. Standard Oil had been broken up by the Supreme Court in 1911, but the resulting companies, which would become Exxon, Mobil, Chevron, and others, were still largely controlled by the same shareholders, the same families, the same financial interests. These interests had a problem. They had invested billions in oil production, refining, and distribution. They needed customers for all that petroleum, and automobiles were their best customers. An electric car didn't need gasoline, ever. If Ford and Edison succeeded in mass-producing an affordable electric vehicle, it could devastate demand for petroleum. Millions of cars that would never visit a gas station. Millions of customers lost forever. The fire that destroyed Edison's laboratory was ruled accidental. Maybe it was, but it was certainly convenient. I want to be clear. I am not claiming that the oil industry set the fire. There is no evidence of that. The fire was investigated and determined to be accidental. But I am pointing out that the world's most famous inventor and the world's most powerful automaker announced plans to build a cheap electric car. And then, within a year, a fire destroyed the inventor's laboratory, and the project died. And I am pointing out that the people who would have lost the most from a successful Ford Edison electric car were the people who controlled the oil industry. Draw your own conclusions. What we know for certain is this. By 1920, electric vehicles had virtually disappeared from American roads. The technology that had held 38% of the market in 1900 was gone. It would not return for almost 100 years. You might think the story of electric transportation ends there. The electric car lost, the gasoline car won, and that's just how technology works. May the best machine win. But what happened to electric cars also happened to electric transit. Electric streetcars, electric trolleys, electric railways, the clean, efficient public transportation that connected American cities. They were also destroyed. And in this case, we don't need to speculate about what happened or why. We have a federal court conviction, not theories, not speculation, not conspiracy thinking. A conviction in a court of law with evidence presented, witnesses examined, and a guilty verdict rendered. This is documented legal history. In 1920, America had one of the most comprehensive public transportation networks in the world. Electric streetcars, also called trolleys or trams, connected neighborhoods to downtowns in more than 1,000 American cities and towns. They ran on tracks embedded in city streets, powered by overhead electric wires. Streetcars were clean. They produced no exhaust. They didn't fill the streets with smoke or fumes. Streetcars were efficient. A single streetcar could carry dozens of passengers, far more than individual automobiles. Streetcars were affordable. Working-class Americans could ride them to jobs, shops, and entertainment for just a few cents per trip. And streetcars were everywhere. Over 44,000 miles of streetcar track crisscrossed American cities. 90% of all urban trips were made by electric rail. Only 1 in 10 Americans owned an automobile, and most of them didn't need one for daily transportation. The streetcar was the backbone of American urban life, and then, systematically, over approximately 3 decades, almost all of it was destroyed. In 1936, a company called National City Lines was formed. On paper, it was a bus company acquiring and operating local transit systems around the country. In reality, it was something else entirely. National City Lines was funded by General Motors, Standard Oil of California, Firestone Tire, Phillips Petroleum, and Mack Trucks. Think about those names. General Motors made cars and buses, vehicles that competed with streetcars. Standard Oil and Phillips Petroleum sold gasoline and diesel fuel, products that streetcars didn't need. Firestone made tires, another product that streetcars didn't use. Mack Trucks made heavy vehicles. Every one of these companies had a financial interest in eliminating electric streetcars and replacing them with buses and automobiles. And that's exactly what National City Lines did. Between 1936 and 1950, National City Lines and its subsidiaries, American City Lines and Pacific City Lines, acquired electric streetcar systems in more than 45 American cities: Los Angeles, Baltimore, St. Louis, Oakland, San Diego, Philadelphia, Salt Lake City, Tulsa, El Paso, Montgomery, Beaumont, Cedar Rapids, and dozens more. The pattern was identical in every city. First, National City Lines would buy the local streetcar company. Often these companies were struggling financially. The Great Depression had hurt ridership, and maintenance had been deferred. Second, National City Lines would cut service further. Schedules would become less frequent. Maintenance would be neglected. The system would become unreliable. Third, as ridership declined, which it inevitably did because the service had become terrible, National City Lines would cite lack of demand as justification for eliminating streetcar service. Fourth, the streetcars would be replaced with buses. Diesel buses, supplied by General Motors. Burning fuel, supplied by Standard Oil and Phillips. Rolling-on tires, supplied by Firestone. Fifth, the streetcar tracks would be torn up. The rails would be sold as scrap metal. The overhead electric wires would be removed. And then National City Lines would move on to the next city and repeat the process. In 1946, a retired naval officer named Edwin J. Quinby began to see the pattern. He investigated National City Lines activities and was alarmed by what he found. He wrote letters to transit officials across the country, warning them, "A careful, deliberately planned campaign to swindle you out of your most important and valuable public utilities, your electric railway system." Most officials ignored him. Quinby was seen as a crank, a conspiracy theorist, a man tilting at windmills. But his warnings eventually reached the United States Department of Justice. Federal investigators began looking into National City Lines. They examined the company's ownership structure. They traced the flow of money from General Motors, Standard Oil, Firestone, and the others. They documented the pattern of acquisition, deterioration, and conversion that had played out in city after city. In April 1947, a federal grand jury in Los Angeles handed down criminal indictments. General Motors, Standard Oil of California, Firestone Tire, Phillips Petroleum, Mack Trucks, and 9 individual corporate executives. The charge: criminal conspiracy to monopolize interstate commerce in the sale of buses, fuel, and related products to local transit companies. The trial lasted months. Prosecutors presented evidence showing coordinated action among the defendants. The same investors, the same tactics, the same outcome in city after city. A systematic campaign to eliminate competition from electric rail and replace it with products sold by the conspirators. The defense argued that they were simply businessmen responding to market forces. Streetcars were obsolete, they said. Buses were more modern and flexible. They were giving the public what it wanted. The jury deliberated and found them guilty. In 1949, General Motors and its co-conspirators were convicted in federal court of conspiracy to monopolize interstate commerce. This is not a theory. This is not speculation. This is United States versus National City Lines, Incorporated. The case is in the court records. You can look it up. It happened. American corporations were found guilty of conspiring to destroy public transit. And the punishment? For systematically dismantling electric streetcar systems in 45 American cities? For destroying public infrastructure that had been built over decades with public investment? For eliminating clean, efficient, affordable transportation for millions of Americans? $5,000. The total fine for all defendants combined was $5,000. General Motors alone earned over $1 million every single day in 1949. The fine was less than 5 minutes of GM's daily revenue. It was pocket change, a rounding error, a joke, and the streetcars, they never came back. Los Angeles once had over 1,000 miles of electric rail. The Pacific Electric Railway was one of the most extensive transit systems in the world. Red cars and yellow cars connected the entire Los Angeles basin, from the beaches to the mountains, from downtown to the suburbs. After National City Lines, it was gone, replaced by freeways and buses. Los Angeles became the most car-dependent major city in America. The city of smog and traffic and endless sprawl. The tracks were never rebuilt. The streetcars were never replaced. A century of public investment was erased, and America became a nation of automobiles. You might think this is all ancient history. Cautionary tales from a different era, when corporations were less regulated and consumers had fewer choices. Surely we learned our lesson. Surely it couldn't happen again. In 1996, General Motors, the same company convicted of conspiring to destroy electric transit, built the most advanced electric car the world had ever seen. They called it the EV1. The EV1 was not a concept car or a prototype or a publicity stunt. It was a real production vehicle that real people drove on real roads, and it was remarkable. 0 emissions. Not reduced emissions, 0. The EV1 produced no exhaust whatsoever. Acceleration from 0 to 60 miles per hour in under 8 seconds. This was a sports car, not a golf cart. A range of over 100 miles on a single charge. Later improved to 140 miles with upgraded batteries. Enough for any normal daily driving. The most aerodynamic production car ever made, with a drag coefficient of just 0.19. Every curve and surface was optimized to slip through the air with minimal resistance. Regenerative braking that captured energy when slowing down and fed it back into the battery. You were charging the car every time you took your foot off the accelerator. The EV1 was a technological marvel. It represented the state-of-the-art in electric vehicle design, and people loved it. The EV1 was only available in California and Arizona, and only through a lease program. GM refused to sell the cars outright. But within those limitations, it developed a passionate following. Celebrities drove EV1s: Tom Hanks, Mel Gibson, Alexandra Paul. They weren't just customers. They were advocates, evangelists for electric transportation. Engineers and technologists drove EV1s. They understood the technology and appreciated its sophistication. Environmentalists drove EV1s. They saw it as proof that clean transportation was possible, practical, and desirable, and ordinary commuters drove EV1s. People who just wanted a reliable car that didn't require gas stations found that the EV1 fit perfectly into their lives. One driver said, "It was just a car that I took home, plugged in at night, got up the next morning. It was like having a gas station in my garage." Another said, "It was the most reliable car I ever owned." These weren't environmentalist slogans. These were genuine user experiences from real customers. But there was a catch. General Motors refused to sell the EV1. You could only lease it. And buried in the lease agreement was a clause that gave GM the right to take the car back at any time, for any reason. Customers didn't own their EV1s. They were just borrowing them. Meanwhile, even as GM was publicly promoting the EV1, the company was privately spending millions of dollars lobbying against the regulations that had required them to build it. The EV1 existed because of California's zero-emission vehicle mandate, a 1990 regulation that required automakers to sell a certain percentage of zero-emission vehicles in the state. Without that mandate, GM would never have built the EV1. GM and other automakers lobbied furiously to weaken and eventually eliminate the ZEV mandate. They argued that the technology wasn't ready, that consumers didn't want electric cars, that the mandate was government overreach. In 2001, the California Air Resources Board caved to industry pressure and gutted the ZEV mandate. The requirement to sell zero-emission vehicles was effectively eliminated, and GM made its move. Every EV1 lease was terminated. Every vehicle was recalled. The customers, the people who had driven these cars daily, who had integrated them into their lives, who loved them, were told they had to give them back. They begged GM to let them buy the cars instead. They offered to sign waivers accepting any liability for maintenance or repairs. They pooled their money. 78 people offered $1.9 million for the remaining EV1s. GM refused. The company sent flatbed trucks to collect the vehicles. Security guards accompanied the trucks. Customers watched, some in tears, as their cars were loaded up and hauled away. The EV1s were taken to a facility in Mesa, Arizona, and they were crushed, nearly every single one. Industrial car crushers flattened them into cubes of scrap metal. The most advanced electric vehicles ever built were destroyed. Activists held protests. There was a candlelight vigil, a mock funeral for the EV1. Former customers and environmentalists blocked the trucks, trying to prevent the destruction. It didn't matter. GM crushed them anyway. The director of a documentary about the EV1 called "Who Killed the Electric Car" later said, "When it all happened, we just stood there and said, 'What are you guys doing?'" The sight of seeing them destroyed before most people ever got to experience them was really quite a shocking moment for us. Only about 40 EV1s survived the crusher. Most were donated to museums and universities with their drivetrains disabled, the electric motors removed or destroyed, making them permanently inoperable. One functional EV1 was given to the Smithsonian Institution. It sits there today, its battery long dead, a monument to what might have been. Years later, Rick Wagoner, who served as GM's CEO during this period, was asked about his biggest professional regret. His answer, killing the EV1. The man who oversaw the destruction of the EV1 later admitted it was the worst decision of his career. But by then, it was too late. The cars were gone. The technology was set back by a decade. The momentum was lost. Or was it? The destruction of the EV1 had an unintended consequence. It made people angry. It convinced them that the big automakers would never build electric cars unless forced to. It showed that if electric vehicles were ever going to succeed, someone outside the traditional auto industry would have to build them. Elon Musk wrote years later, "Since big car companies were killing their EV programs, the only chance was to create an EV company, even though it was almost certain to fail." The destruction of the EV1 inspired the creation of Tesla. An outsider had to build the car that the insiders kept killing. Let me ask you a question. How many times does something have to happen before we stop calling it a coincidence? In 1900, electric vehicles held 38% of the American automobile market. They were clean, quiet, safe, and popular. By 1920, they were essentially extinct. In 1914, Henry Ford and Thomas Edison, the two most capable men in America to accomplish such a thing, announced plans to build a cheap, mass-produced electric car. The project died under mysterious circumstances and was never revived. In 1949, General Motors and its partners were convicted in federal court of conspiring to destroy electric streetcar systems in 45 American cities. The fine was $5,000. The streetcars never came back. In 1996, General Motors built the most advanced electric car in the world. Customers loved it. GM crushed them in a junkyard 4 times. 4 separate instances where electric transportation was ascendant or could have been ascendant, and 4 times it was destroyed. Is this a coincidence? Is it just bad luck that the same technology keeps dying over and over? Or is there a pattern here? Every time electric vehicles threaten to succeed, powerful interests, oil companies, automakers, the industrial complex that profits from gasoline, found ways to stop them. Through market manipulation, flooding the world with cheap oil after Spindletop, making gasoline artificially inexpensive. Through technology appropriation, using electric motors to solve the gasoline car's biggest problem, then claiming electric vehicles were obsolete. Through legal conspiracy, systematically buying and destroying electric transit systems, accepting a slap on the wrist when caught. Through corporate sabotage, building electric cars only when forced to by regulation, then crushing them when the regulations were weakened. The electric car didn't fail. It was killed. Again and again and again. And we paid the price. Every gallon of gasoline you've ever bought, every oil change, every smog-filled city, every war fought in the Middle East to secure oil supplies, every hurricane intensified by climate change, every wildfire season that grows longer and more destructive, every child with asthma from breathing exhaust fumes. None of this had to happen. The technology existed. It worked. People loved it. And it was systematically, repeatedly, deliberately destroyed by those who profited from its absence. Today, finally, electric vehicles are making a comeback. Tesla proved that electric cars could be desirable, not just dutiful, that they could be faster, sleeker, and more technologically advanced than gasoline cars. Norway will effectively eliminate gasoline car sales within the next few years. More than 80% of new cars sold in Norway are already electric. China produces millions of electric vehicles annually. The world's largest auto market is going electric faster than anyone predicted. Every major automaker, including General Motors, now has an electric vehicle program. Ford is electrifying the F-150, the best-selling vehicle in America. Electric trucks, electric SUVs, electric sports cars are hitting the market. The charging infrastructure is expanding rapidly. You can drive an electric car across the country today, charging along the way, just as Thomas Edison did in 1910. The electric vehicle is back. But I want you to understand something. This is not new technology. This is not some 21st century innovation. This is not the future arriving at last. This is recovered technology. This is technology that worked in 1900, that Clara Ford chose over her husband's Model T, that Thomas Edison believed was the future, that was killed again and again by people who made money from its absence. We didn't just lose electric cars, we lost 100 years. 100 years of clean air that we didn't breathe. 100 years of quiet streets that we didn't enjoy. 100 years of energy independence that we didn't have. 100 years of climate stability that we didn't preserve. Your great-great-grandmother could have driven an electric car. She did drive an electric car, if she could afford one in 1900, and then someone took that option away. From her, from her children, from her grandchildren, from you. Now you know who, now you know how. And now, finally, we're getting it back. The electric car isn't new technology. It's old technology that was suppressed for a century. It's a resurrection, not an invention. And maybe this time, we won't let them kill it again. Clara Ford drove her last electric car in the late 1930s. By then, electric vehicles had been off the market for years. The Detroit Electric Company had stopped production. The charging stations had closed. The infrastructure had disappeared. Clara was in her 70s. She had been driving electric cars for nearly 30 years. And now, for the first time in her adult life, she had no choice but to drive something else. We don't know what she drove after that. Presumably a Ford, finally. Her husband had died in 1947. The man who had revolutionized gasoline transportation was gone. But Clara had always known the truth. She had looked at the gasoline car, noisy, smelly, dangerous, complicated, and she had said no. She had chosen something better, something cleaner, something quieter, something that just worked. And she had been right. It just took the rest of the world 100 years to catch up. Clara Ford died in 1950. She never saw the streetcar conspiracy trial. She never saw the EV one. She never saw Tesla or the modern electric vehicle revolution. But she knew, back in 1908, when her husband bought her that first Detroit Electric, she knew. The electric car was better. It always was. And now, finally, it's being allowed to live.